And now that you know the vast improvements with WSL2, that's the reason why around October 2019, we had WSL2 integrated with Docker. And Docker had mentioned as once WSL2 is generally available, we will automatically switch on to the WSL2 backend on compatible machines like Windows 10, of course, and basically moving away from the Hyper-V backend. And that's what we experienced. We are now using the WSL backend. And what Docker did was it listened to its users. And that's something that I'm happy with as well. But having said that, they actually wanted to change a few things regarding the WSL integration. So the first thing, running in an isolated environment. So in order to avoid interlocking and other side effects from other apps running with WSL2, they wanted to run it on a separate namespace for network, PID, and mount. So namespace is like the kernel partitioning its resources so that one set of the process sees one set of resources and another set of process sees another set of resources, or in simple terms, so that they don't overlap or collide with each other. There are various namespaces like user namespace, mount namespace, network namespace, and more. And you can read about them in the documentation. Second, they didn't want to re-implement everything that they had already done with the Hyper-V VM. They did not want to take the additional overhead for that. And the third one was to have complete integration with the existing UI so that it does not create confusions for the users currently using the application. That's good, isn't it? Now let's see what and how things changed from Hyper-V VM backend to WSL2 based engine for Docker. So before moving on to the WSL2 integration with Docker, let's get a better context and talk more about the Hyper-V backend architecture. So first things first, by now we are already sorted and we are fully sorted, and we know in the Hyper-V backend, the Linux VM that Docker used ran on Hyper-V, which was built using the Linux kit, which we already had discussed a couple of minutes back. I hope you remember that. So here, running a Linux kit VM gave Docker the flexibility to incorporate the components that they wanted, which could be used for both Hyper-V and Mac VMs. So what they did was they packaged all the components into the Docker desktop, like lifecycle control service, diagnostic service, aggregation log service into a ISO that was Docker desktop ISO. And on top of the base distribution, they mounted another ISO that was version pack ISO, which contained the binaries, deployment scripts, and upgrade scripts related to the specific version of Docker engine. And then in order to store container images and configuration files, they attached a virtual hard drive before starting the virtual machine. And they did a very interesting and logical thing by introducing a proxy that would expose the Unix socket as Windows named pipes using the Hyper-V sockets, so that the services mentioned above could be reachable to the Windows side. Smart, isn't it? So if you're not aware of what named pipes are, you have to ask yourself, are you aware of pipes in general? So the easiest way to remember pipes is to imagine a real pipe. So you can push water from one end to another using a pipe. So it tells you the pipe velocity and the amount of water that can flow from it. So one opens the tap and the other collects. But in Windows, the pipes are a bit more complicated than this. So pipes in Windows are used for inter-process communication, or IPC, where a section of memory is used by process for the sake of communication. So the process that creates the pipe is called the pipe server, and the one that connects to that is the client pipe. So one process writes to the pipe and the other one reads from that. And there are two types of pipes. So one is anonymous and the other one is named pipes. So anonymous pipes, or what we also know as pipes in Linux, are used for simplex communication, or in other terms, we say we use it for one-way inter-process communication. And this is unidirectional, and here from one end the process A can either write and read, and from another end the process B can read and write. But even though we can perform read and write operations at the same time, this cannot be used over the network. That's why we jump onto the named pipes in Windows. We also know this as make FIFO for people who are well versed with Linux, so they might know this as make FIFO. So this is more popular because it supports client server architecture or client server communication. And it also as well supports two-way or duplex communication. So this way the server can communicate with multiple clients. And if the server is communicating to the client 1, then client 2 and client 3 will be in the wait state. But don't worry, there are both synchronous and asynchronous named pipes that you can make use of, but that's a topic for another time. And the advantage here is that named pipes can be used over different systems over the network as well. Now let's see the WSL2 implementation of Docker. So here if you see, it may not be that obvious, but unlike the Hyper-V backend, the Linux Kit VM or the distribution that was running in a VM is now changed and is running in a container. But for the process to work, we need to create namespaces, isn't it? And as Docker mentioned before, they wanted to have separate namespaces. So for this, Docker actually creates two WSL distributions, which are Docker Desktop and Docker Desktop Data. So Docker Desktop here will call the bootstrapping distributions, which eventually will create the Linux namespaces. And Docker Desktop Data will call the data store distro, which will help us to act as a backup store for container images instead of using the virtual hard drive. It's more evident when we see them side by side. So you can as well understand just by looking at the comparison here that Docker is hinting that the bootstrapping distribution replaces the Hyper-V and the data store distro replaces the VHD or the virtual hard drive. And moving on, for the file and network shares, the bootstrapping distro manages the mounting for Windows 9p shares. So if you know, 9p or Plan 9 is a file system or mounting protocol that is used in a distributed environment. So the Linux container can make use of it. And this also manages the lifecycle of the Linux Kit container. And last but not the least, the version pack ISO that you see here remains the same as it was in the Hyper-V backend. And what are the advantages to this? Yes, it makes Docker achieve 15 times faster start time. It provides dynamic resource allocation, and now it can run on environments with lower memory as well. Cool, isn't it? When we installed Docker, we installed it with WSL2 enabled, and that is why we did not get the option to provision spaces and resources to the Docker engine. But how does Docker get this dynamic resource allocation? So as we now have realized, the main objective for Docker was to move away from the concept of managed VM. So with WSL2, you get a feature for dynamic memory allocation, which helped the cause for better performance. What WSL provided was a property of memory reclaim. Previously, when we created VMs, the memory would be kept occupied even after we were done with the workflow cycle or by the Linux kernel, and thus the memory requirement would increase for the WSL2 VMs. But with memory reclaim, the amount of memory which is no longer needed by Linux will be returned back to the host and thus reducing the footprint. This as well includes the caching. And you may ask how? So listen to this very carefully. So this is a Linux kernel feature, and what it does is that it allows block of contiguous memory to be returned back to the host if and when they are no longer required by the Linux guest. So what WSL did is that they incorporated this feature to the Linux kernel for WSL2 using a kernel patch and updated the Hyper-V to support page reporting. So if you know, Linux already had this feature long ago, which was free page reporting, which is basically an API by which a device can register a receive list of pages that are currently unused by the system. So that is the same thing that they have tried using, but by using the patch. So in WSL, the host would periodically compact memory in order to ensure free memory is available. And it's not that you can't change it. Yes, you can do that now as well by modifying the .wsl config file if you have enough permissions. And this actually happens when the CPU is idle, and you can validate this by looking for the message performing memory compaction in the dmessage command output. But what if we still want to use the Hyper-V backend approach? Can you do that? Yes, you can. Let's check it out. So what you can do is you can go to the settings, and here you can see the option in general, use the WSL2 backend engine. WSL2 provides better performance than the legacy Hyper-V backend. What you have to do is you have to just uncheck this and you have to apply and restart. Okay, so the Docker engine has started and I can just go to the settings. And now as this has been disabled, the WSL2 based engine is disabled, it will fall back to the Hyper-V backend. Yes, now you see the resources available to you. Here is where you can change it. Docker desktop VM data. So you can assign the number of CPUs that you want. You can assign the amount of memory that you want. It's currently at 2 GB. Swap is at 1 GB. Disk image size is 64 GB. This is the file sharing settings. This is the proxy. This is the network. This remains same, but the option that you get is the resources that you can change. Going back to the Docker engine, so this is the configuration file. And here you can enable the Kubernetes as well, which will start a Kubernetes single node cluster when every time the Docker desktop actually starts. So you can make use of it. But we'll see this after the Docker session is complete. So we'll move on to Kubernetes after that. So that was interesting, isn't it? But you might still think that, is it that we are going to do away with the Hyper-V backend approach? But among these two, which one is the most practical solution? And for now, I would say it depends.